Let's discuss a question from theory of machine. So this is from a compound cyclic gear train problem where the axes of the gears are fixed. They can only rotate about their own axis. The axis cannot change. Okay. So now before going to this problem, just let's understand one thing. When two gears are in mesh, okay, so then the ratio of speeds, this is first gear, this is second gear, ratio of speeds vary in the inverse ratio of their number of teeth. Basically here the velocity at the point of contact is same r omega, which is nothing but r 2 pi n by 60. Now that is same for both. So that velocity, whether you compute from 1 or 2, that is same. So r1 n1 is equal to r2 n2. So it can be seen that the larger gear, they vary in the inverse ratio, so the larger gear will have less speed and the, the smaller gear will have more speeds. Now larger number of gears will have larger number of teeth, the smaller gear radius gear will have smaller number of teeth. So r, again with the modulus you can relate teeth. So T1 by T2 is N2 by N1. So that's, I have briefly shown this equation, but again this is logical. The larger radius gear will have large number of teeth and less speed. So the teeth and the number of teeth and the speed, they vary in the inverse ratio. Okay, so this can be applied for the gears which are in mesh only. So let's apply for A and B combination. So NB by NA is TA by TB. TA is 24 and TB is 56. Similarly, let's apply for C and D. ND by NC is TC by TD, which is 30 by 80. Okay, now let's apply the similar equation for E and F because they are in mesh. So NF by NE is TE by TF, which is 32 by 72. Now I need NF, right? So let's multiply these three and let's see what we get. NF by, multiply these three equations, so ND by NC and NF by NE. Okay, so 24 by 56, 30 by 80 and 32 by 72. So just multiplying these three equations. So that is the thing. Always write down for pairs of gears which are in mesh. You can individually write these equations and then just multiply. Now because B and C are on the same shaft, so they'll have same speed. So B and C gets cancelled. E and D are on the same shaft, so they'll have same speed, so that gets cancelled. So left side is basically NF by NA. Okay, and the right side is just numbers, you can just find out, and that comes out 0.07143. Now NF, so thing is that when you have a chain of shafts like this and compound gears, so if you know the speed of A, you can find out the speed of F, provided that you know the number of teeth on all the gears. So that is what is said here. So A is 800 rpm, 0.07143. So this comes about 57 rpm. So about 57. So you can bring a reduction from 800 to 57 rpm by using this gear train. So 57 is the answer. Thank you.